Hello everyone. Once again, welcome you all in the journey of mathematics learning. Today's chapter is last chapter from algebra, that is arithmetic progression. Before we have completed the chapters from the algebra that are polynomials, pair of linear equations in two variables, quadratic equations, and it's turn to explore with arithmetic progression. So first of all, you should understand what is the meaning of arithmetic progression. Before that, what is the meaning of this progression? Progression means a kind of sequence or arrangement of the numbers or objects. Now, under what condition we can say some of the arrangement of the numbers are arithmetic sequence or arithmetic progression? First of all, let us take one example. Very simple example, 1, 2, 3, set of natural numbers. Next, let's take 2, 4, 6, 8. Another, we'll take the odd numbers 1, 3, 5, 7. Another, we'll write down the prime numbers 2, 3, 5, 7. You can see here, these are some types or sequence of the numbers. Now, are they following the same types of pattern or do we have any other form of the patterns? First of all, look at here. This 2 is 1 more than this one. This 3 is 1 more than this 2. That means difference of 2 and 1 is 1. 3 minus 2 is also 1. So here we can say that difference is 1. Now second one, you just take it out here. There is 2, 4, 6, 8. 4 minus 2 is 2. 6 minus 4 is 2. 8 minus 6 is 2. So if you'll go like this, second minus first, third minus second, two consecutive terms, the difference of two consecutive terms we are getting same. Here is also the same. 3 minus 1 is 2, 5 minus 3 is 2, 7 minus 5 is 2. We'll check it out here. 3 minus 2 is 1, 5 minus 3 is 2, 7 minus 5 is 2. Now look at here, in these three sequences, in these three forms of the numbers, we can see there is one exact particular pattern is followed, but this is not following any pattern. So whichever number will follow the same pattern in that sequence, such type of numbers are known as the arithmetic progression. To check the arithmetic progression, just you have to check second term minus first term should be equal to third term minus second term, should be equals to fourth term minus third term, and so on. So formally, we have a definition. Arithmetic progression is a sequence of numbers in a specific order where the difference between any two consecutive terms are same. You can see here specific order is mentioned. The specific order means that I have told you just before that the second term minus first term, third term minus second term, just like that. There should be some pattern. Such type of sequences are known as arithmetic sequence or arithmetic progression. Now next thing is that what is the name of that difference that we have obtained before? That means second term minus first term, third term minus second term. What is the name of that difference? The name of the difference is common difference. Common means same, same difference, but that should follow the specific order. Clear? That you have to check every time. Let me write some of the examples here. 3, 6, 9, 12, and so on. If there are finite numbers, that we used to say that the finite, if there exist infinite numbers, then we can say these are the infinite sequence. Now just check it out. 6 minus 3 is equals to 3. 9 minus 6, that is also equals to 3. 12 minus 9, that is also equals to 3. So it means that this is also an arithmetic progression. Next, 1, 8, 15, 22, and so on. Let us find it out. What is the common difference here? 8 minus 1, which is equals to 7. 15 minus 8, which is also equals to 7. 22 minus 15, that is also equals to 7. So differences are same, means this is also an AP, and here you can say the common difference is 7, and this common difference is denoted by a small d. Now you can see here I have given you two examples. In both the examples you can see that the common difference are positive. Is it necessary that the common difference should be positive always? The answer is no. Let us check it out. This one, 29, 25, 21 and so on. Just check it out. Find the difference for this. 25 minus 29, which is equals to minus 4. 21 minus 25, that is also equals to minus 4. It means that difference are same, means this is also an AP. It means that to be an AP, it is not necessary that D should be always positive. Here we found that the value of D is positive. Here we can see the difference is negative. And what other option that we have? The third option, that difference may be 0 also. So what type of sequence will be there if the difference, common difference is 0? That is, just write it down, the same numbers. 2 minus 2, 0, 2 minus 2, 0, 2 minus 2, 0. That means constant value, same value. If it is repeating, then such type of, for such type of sequences we have the common difference is 0. So these are some ideas to find it out, the common differences. So always remember, to find the common differences, what you need to do? Second term minus first term, that should be equals to third term minus second term and so on. These values we used to say that common differences. Now next, common difference. If you can see that D is positive. In the previous example that we have taken, there we find it out in the first example that the common difference was positive. So AP was increasing. Another example. Let's start from 20. 20, 28, 36 and so on. You can find it out. For this, the common difference is 8. Which is positive, that's why AP is increasing. Second one, if D, the value of D is negative, then AP will be decreasing. For example, let's start from 20 only. 20, 13, 6, so on. 13 minus 20 is minus 7 and 6 minus 13 is also minus 7. Here the common difference is negative. So what can we say that for this? For this, the AP is decreasing. Now third one, if D is equals to 0, if the common difference is 0, we already have seen the example, then the AP is constant. That means same number is repeating. Let's say for example 5, 5, 5 and so on. For such type of APs, the common difference is 0 and we used to say that the AP is constant AP. AP has the common difference and that common difference must be integer. You might be thinking, but that is wrong. So to prove it, I will give one another example to show that it is not necessary that the common difference always will be integer. So for that, I'll write it down this. Say for example, 2, 3.5, 5, 6.5 and so on. Just check it out. 3 minus 5 minus 2, which gives us 1.5. And next is 5 minus 3.5. 5 minus 3.5 is also 1.5. So 6.5 minus 5, that is also equals to 1.5. It means that the fraction or rational number is also their possibility to be the value of common difference. It means that by looking into these examples, we can say that the value of D is any real number. Not only that, in the higher studies, we may get D is constant value, D may be anything. The common difference, the value of common difference may be anything, but only to satisfy to be an AP, the second term minus first term should be equal to third term minus second term. If it follows that pattern and whatever that difference we will be obtaining, that difference we used to say the common difference. For now, we will take that D is a real number. In real number, you know that every type of numbers will be there. That is, the types of numbers are natural number, whole number, integers, rationals, irrationals. This all collections will make the real number. Now, one example you can see here on the screen. that is square root of 2, square root of 8, square root of 18, comma, square root of 32. So we want to check whether this is an AP or not. You might be thinking that root 8 minus root 2, yeah, this is equals to root 6. But this is completely wrong. We cannot subtract like this. So if we cannot subtract like this, then how to subtract it? For that, what you need to do first thing, first of all, root 2, one of the term is there. For root 8, you can go with 2 multiplied by 2 multiplied by 2. Next for 18, 2 3s are 6, 3s are 18. And next is 2 2s are 4, 2s are 8, 2s are 16, 2s are 32. So on. This comes by prime factorization. Now look at here. That is, we can say that this is square root 2. If 2 are there inside the square root, we can take outside one of them, because I am explaining these all 2's within the square root have power half. But if you take outside, the power will be 1. So if two numbers are multiplying with the same base and powers are half, then definitely by the laws of indices, the power will be added. So half plus half becomes 1. So that's why root 2, root 2. Now here 3 has a pair. This 2 makes the power 1. So 3 will be outside. 2 does not have any pair. It will remain inside. And next, here you can see that 2 pairs of 2 are there. So 2 multiplied by 2 is square root of 2. So what we are getting here is square root 2, 2 is square root 2, 3 is square root 2, and 4 is square root 2, so on. Now we have simplified form of the given sequence. So let us check it out. The second term minus first term. 2 root 2 minus root 2. It gives us square root 2 only. You can take that root 2 as a kind of variable. For this 2x minus x, it gives us only x. Just like this, only to clear your concept. 3 root 2 minus 2 root 2 is also root 2. Next, 4 root 2 minus 3 root 2, that also gives us root 2. So here we can see that the differences are same in a particular specific pattern, specific form. Then we can say this is square root 2 is square root 8 is square root 18, comma, dot 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 will form an AP. To check the AP, don't be in a hurry. First, check the sequence of the numbers properly. If it is needed to simplify, first simplify it, then only proceed to find it out, the differences. Don't make mistakes, because one mistake, game over in mathematics. So this is one of the example that we can see here. Now actually, how can we relate this AP with our day-to-day life? Now take one example. If someone asked you, if you move 2 kilometers, where will you be reaching? Then what will be the answer? You might be giving the answer this place, this place, this place, but that person who is asking you has not mentioned from where that you have to start. So AP needs the starting point and the distance, that is gap we used to say. Clear? So if we have a starting point and gap, then we can find it out other gaps, other places in our day-to-day life. Suppose there are places A, B, C, D, and distance between these places A to B is 10 kilometer, B to C is also 10 kilometers, C to D is also 10 kilometers. If someone asked you, if you move 10 kilometers, where will you be reaching? So answer is invalid. We cannot give the answer. The invalid answer will be there because we don't know from where we are starting. If someone asked you, if you'll start from B in one of the direction, okay, suppose this is left, this is right. Direction is also necessary for a specific form. We already have seen there in a specific order. So for the order, there should be the direction. If someone asked you, if you are starting from B towards right, after 10 kilometers, where will you be reaching? So the answer will be clearly C. But if someone asked you, if you are starting from B, after 10 kilometers, where will you be reaching? But the answer will not be fixed. It may be anywhere. If you'll see in the figure itself, it may be A also, it may be C also. That's why every time you have to follow that specific order. And this AP helps us to understand our real life problems also. That's why to solve the problems in AP, what we need the first term, starting point, and we need the gap, that is common difference. Keep this thing in your mind. Topic, that is general or standard form of an AP. How to represent some AP in a general form, how to generalize the AP. The simple thing is that, just look at here. Just count it down, first, second, third, fourth, fifth term. Suppose you know this value and you know the gap. Then how can we obtain this second term? First term plus common difference. You will be getting second term. To get this third term, first term plus one difference, two differences, A plus 2D. To reach here, first term plus one gap, two gaps, three gaps. You will reach there in the fourth term. To reach this fifth term, how many gaps that you need to add? You need to add 4 gaps. Remember that. To find, suppose you need to find it out 10th term, then you are starting from the first term, and how many gaps that you need to add to get the 10th term? 9 gaps that you need to add. You will be getting 10th term. That means you need to, if you want 10th term of this AP, very simple, A plus how many D? 9D, because starting 1 is already there. Without adding any differences, we are getting the first term. That's why to get the other terms, just we need to add the gaps. So to reach the 10th term from the first term, how many gaps that we need to add? We need to add 9 gaps. Clear or not? So this is general form. You can see that how many D are there in the first term? 0. How many D are there in the second term? 1. How many D there in the third term? 2. So how many D's are there? N minus 1. That means this is our nth term. So here you can say that A is first term, D is common difference, and what is this N? N represents the position of particular term, or we used to say in AP that the number of terms in an AP. Clear or not? Just remember this. Sometimes the questions will be asked in the boards that if first term will be given to us and common difference is given to us, if you are supposed to write it down, then AP, just you have to add common difference one after another to get the next number, and that definitely will be in this form. So for the same, I will give one example. If someone give you that first term is 2 and common difference is 3. To write an AP, general form is first is 2, to get the second, 2 plus 3 is 5, to get the next gap, 5 plus 3 is 8, to get the next 8 plus 3 is 11, and so on. And this is A first term, this is A plus D, here A plus 2D, 2 plus 2 reach 8 from 2, 2 plus 3 plus 3, that means A plus 2D. To reach here, how many D's? A plus 3 gaps. This is one of the way to write an AP if you know the first term and the common difference. Or you can use directly there in the sequence that A plus D, comma A plus 2D, comma dot dot dot, and here you can put that in place of A 2, here is 2 plus 3, here is 2 plus 2 multiplied by 3, and so on. You'll be getting that 2, 5, 3 2s are 6, 7, 8, and so on. This is also one of the method to write an AP if you know the first term and the common difference. Now next, general term. General term means nth term that we used to say in an AP, that we already have seen the formula. Just look at here. I have explained you. By looking from the first, this gives your nth term. So the formula to find the nth term is A plus n minus 1D, where A represents the first term, D is common difference, and is the specific term, or we used to say the number of terms in an AP. So what is the importance of this formula? To know the importance of this formula, look at here. If you have number like this, starting from 1, common difference is 1, you can say this is set of the natural numbers. Which is the first term? The first term is 1, second term is 2, third term is 3. We can guess 10th term is 10, isn't it? 50th term is 50, 100th term is 100. So this is easy. Without using any formula also we can find it out, the particular term, value of particular term. If you have 2, 4, 6, 8 like that, first term is 2, second term is 4, third term is 6. Here also we can guess 15th term will be 30, 45th term will be 90, 100th term will be 200, 1000th term will be 2000. That we can get by looking into the form of the sequence. But if you have a sequence just like this, starting from 3, and if you have a gap like 7, just a 3, 10, 17, 24, dot dot dot. First term is 3, 10 minus 3 is 7, 17 minus 10 is 7, 24 minus 7, 17 is 7. So here you can say that the common difference is 7. But if someone asked you, what will be the next term? If someone asks you what will be the next term, then here for the next term we can write it down 31 by adding 7 on it. If you want next term, if you add 7, you will be getting another term. But if someone asks you to find it out, suppose 15th term, that also by writing it we can obtain. But if someone asks you to find it out 28th term, then how to find it out? For that we need a general form or general term of an AP that is given by nth term. So for 20th term, if you use the formula is an is equals to a plus n minus 1d. It means that if there is n, the number of gaps should be 1 less than that n. So here we can write it down a plus which term what we need? 20th term. So 27 gaps should be added to the first term. So first term is 3 plus 27 into our gap. The gap is 7. So here we can say that 3 plus 7 sevens are 49. 7 twos are 14 plus 4 is 18. 189. If you add 3 on it, we will be getting 192. So if we have a sequence like this 3, 10, 17, 24 dot dot dot, if someone asks you to find it out the 20th term, we can find it out easily without taking any more time using the formula, that is 192. But here, just like this, if someone asks you to find it out the 1000th term, that also we can obtain using the formula. So that is the importance of this general term or nth term of an AP, that is an is equals to a plus n minus 1d. Sometimes this an will be denoted with tn also. Don't be confused with that. So next thing is that sum of the first n terms. Previously, general term, nth term means, what is that nth term? Nth term means particular, specific value of that particular term. Here you are adding the number still here. Suppose you have 5 numbers, first term, second term, third term, fourth term, fifth term. Specific values are there. If someone asks you to find it out sum of the first 2 terms, that you need to add this and this. If someone asks you to find it out the first sum of the first 3 terms, then you have to add 1, 2, 3. From the first you have to add 3 terms. So that is the concept of the sum of the first n terms. The formula is Sn, denoted by this. Sum of the first n terms will be denoted by Sn, and Sn is n divided by 2, 2a plus n minus 1d. And next is that you can see that Sn is equals to another form, that is n by 2 into a plus an. That second one is obtained from first only. Just look at here. Sn is equals to, first say that n by 2, 2a plus n minus 1d. If you replace this n by 2, not replace, if you write it down this 2a as a plus n minus 1d, then look at here, this a plus n minus 1d will form nth term. So n by 2 a plus an. So I want to tell you one thing, that how to find it out the sum of the first 100 numbers, 100 natural numbers, 1, 2, 3 and so on. You want to add till 100. So if you use the formula Sn, it will be given by, there are 100 terms, this formula is n divided by 2, 2a plus n minus 1d. So this is the formula. In place of n, you can put 100 divided by 2. 2 into first term is 1, plus n minus 1 means 99d, and in place of d common difference is also 1. So it will be 100 divided by 2 multiplied by 2 ones are 2, 99s are there, so we will have 101. 2 gives us 50, so it will be 5050. Do we have this method only, this formula only, or do we have other ways to find it out the sum? So for that, one thing you can use for the sum of the first n natural numbers, that is given by 1 plus 2 plus 3 plus dot 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 plus n. It can be written as n into n plus 1 divided by 2. So if you use this one also, you will get the same solution. Just there are 100 terms, 100 numbers multiplied by its conjugative 101 divided by 2. It gives us 50. So that is also one of the method, and this is one basic formula to find it out the sum of the first n natural numbers. Clear? Now moving to the next. What is the relationship between an and sn? So an is sn minus 1. Let me explain it, how it works. Let us take one example. Example of odd numbers. Let's start from 5. 5, 7, 9, 11, and so on. First, you know that the first term is 5, 7, second term is 7, third term is 9, 11. What is sum of the first one term? Sum of the first one term is 5, that is first term. So one observation we can make here, S1 is equals to A always. So sum of the first one term means first term. So S2 means sum of the first two terms, that means 5 plus 7, that is equals to 12. But this is not second term. S3 means sum of the first three terms, 5 plus 7 plus 9. 5 plus 7, 12 plus 9, 21. Now S4 is 5 plus 7 plus 9 plus 11. 21 plus 11, if you add 11 on it, we will be getting 32. So these are the sums. Now to get second term, look at here, to get second term, sum of the two terms minus sum of the one term. S2 how much is there? 12 minus S1 is 5. 12 minus 5 is 7. So we got the second term. Similarly, if you want to find it out the third term, so A3 can be written as S3 minus S2. S3 is 21 and S2 is 12. 21 minus 12 will give us 9. So which is the third term. That's why this formula is formed. That means relationship between nth term and sum of the first n terms will be an is equals to sn minus sn minus 1. Suppose you need to find it out 10th term, it will be sum of the first 10 terms minus sum of the first 9 terms. Just remember in this format. If you need to find it out 15th term, it should be sum of the 15 terms minus sum of its first 14 terms. So this is the idea, and this gives us the relationship between an, that means nth term, and the sum of the first n terms. If you want to understand this with this number line, a kind of number line, suppose we'll break in this format. So suppose this is first, this is second, this is third, this is fourth. If you want to find it out this fourth part, then this is actually S4. From there, if you subtract this S3, so S4 minus S3 is giving us this part only, that is this part only, that is equals to A4. So from there, we can get this concept. That means nth term can be written as sum of its n terms minus sum of its n minus 1 terms. So next, if the sum of the first n terms of an AP is 3n square plus 2n, then find its 10th term and nth term. This problem is based on that previous relationship between nth term and sum of the n terms formula. The solution is, first we will solve using the formula that we have written. First thing is 10th term. A10 will be S10 minus S9. So S10 means, look at here, we have Sn is equals to 3n square plus 2n. So here S10 will be 3 multiplied by 10 square plus 2 into 10 this is S10, minus S9 will be 3 into 9 square plus 2 into 9. So here 3 into 10 tens are 100 plus 10 twos are 20 minus, so 9 square is 81, 81 into 3 is 243, 9 twos are 18, so 320 will be here, minus 243 plus 18 will be 8, 9, 10, 11, 4 plus 1, 5, 6, 261, 320, 320 minus 261, 10 minus 1 is 9, and 1, 11 minus 6 is 5, that is 59. So we will be getting 59. What is that 59? That 59, this 59 is actually the 10th term of this AP when the sum of the n terms is given to us. If you want to find it, second one is that nth term. To find the nth term, look at here, Sn is equals to 3n square plus 2n, 3n square plus 2n. You are supposed to find it out an. So the formula for an is Sn minus Sn minus 1. So Sn is 3n square plus 2n minus Sn minus 1 is 3 times n minus 1 whole square plus 2 multiplied by n minus 1. So only that n should be replaced with n minus 1. This is equals to 3n square plus 2n minus here 3 times a minus b whole square, a square minus n into 1 is n, double of that will be 2n, and 1 square is 1, plus 2 into n is 2n, plus into minus minus 2. So 3n square plus 2n minus 3 into n square, 3n square minus 3 2s are 6n plus 3 1s are 3 plus 2n minus 2. So this is equals to 3n square plus 2n minus, we can simplify this part also, 3n square minus 6n plus 2n will be minus 4n, 3 minus 2 is plus 1. So 3n square plus 2n minus 3n square minus into minus plus 4n minus 1. So look at here, 3n square will be removed, 2n plus 4n will give us 6n minus 1. So its nth term, general term will be 6n minus 1. So this is one of the method to find it out, the 10th term and nth term, if some of the first n terms are given to us. Do we have this method only, or do we have another way also to find it out this? If you use this, Sn is equals to 3n square plus 2n. First find it out. S1 is first term. This is first term. S1 will be 3 into 1 square plus 2 into 1. So 3 plus 2, which is equals to 5. So we got the first term. That means this is the value of A. Now we'll find it out S2. Sum of the first two terms. That means 3 into 2 square plus 2 into 2. So 2 2s are 4, 3s are 12 plus 4, which is 16. How to find it out the second term? A2 will be S2 minus S1. S2 is 16, S1 is 5. So this is equals to 11. So this is our second term, A2 we used to say. This is A1, this is A2, and third one, we will find it out S3. S3 will be 3 into 3 square plus 2 into 3. 3 3s are 9, 9 3s are 27, plus 3 2s are 6, which is equals to 33. To find the third term, S3 minus S2, which is 33 minus, how much is S2? S2 is 16, which will give us 17. So this is the third term. So once we obtain this first, second, third term, therefore we can say that AP is first term is 5, second term is 11, and third term is 17, and so on. So what is the first term? 5. Now to find the common difference, 11 minus 5, which is equals to 6. So we have first term also, and we have common difference also, right? Now therefore what will be the 10th term? 10th term will be A plus 9D, which is equals to 5 plus 9 into 6. 9 6 are 54. 54 plus 5 is 59. So 5 plus 9 6 are 54. That is 59. Let us check it out whether that is equal to that previous answer also. Yes, that is 59. Now next, we will find it out its nth term. An will be a plus n minus 1d. So first term is 5 plus n minus 1. D is 6. So 5 plus 6 into n is 6n minus 6 into 1 is 6. So 6n, 5 minus 6 is minus 1. So its nth term is 6n minus 1. That is here we already have obtained. So these are two methods that I have explained just now. If you use the direct relationship also, you will be getting the same solution. Or if you use this one, find it out the AP first, then you use the formula to find it out that particular term, that also can be done. So these all are the problems that we solved here in this video, in this class, are all previous year questions that we have seen. Now, every time whenever you will find it out the problems from the AP, you have to check whether the first term and common difference are given to us or not. Once we have the value of A and D, we can do anything in AP. We can find it out any value in an AP. So for that, you should understand the problem, and without giving anything, question will never ask to find anything. So that's why first check what are the parts that is given to us. Then after, which formula that you need to use, just follow it, properly use it, and simplify it carefully. You will get definitely the correct answer. So keep learning, keep enjoying. More you practice, more you learn. We'll be meeting in the next video. If you like my video, please watch, like, share, comment, and don't forget to subscribe. Thank you.